Hi, I'm Dale Franklin, and what I did in this project was integrate the temperature sensor to the LCD screen, and I wrote the coding so that we could interpret the voltage output of the temperature sensor into a meaningful temperature, and then use that temperature with the LCD screen, and so we could interface with our project.
My name's Andrew Sneischovel, and what I did was I programmed the LCD screen to then print and use the buttons to change the set's temperature that the user would decide, and then taking the value that Dale had figured out from the temperature sensor and compared to the user value, then programmed a way to integrate or to communicate the Arduino to another Arduino board with a driver board for the motors. The integration or the communication required turning the digital pins into a byte of high and low values to then be read as a byte to determine the difference in temperature.
My name is Austin Stevenson. I did the stepper motor interface. We used two stepper motors, one to control the hot and one to control the cold. So it works in such a way that it will slowly adjust and keep readjusting like a scale would. And finally get you to the right set temperature that you wanted to get out of the system. And did the coding for that, and yeah.
So we have here a temperature sensor which sends the voltage all the way back to here, where it then gets converted over to a temperature value. The temperature value then gets compared with what is printed on the screen, which those two values are then compared. The difference between the two is turned into a byte using data register programming, is then sent as high or low voltage, then to this one. Now if the voltage is too high or too low, it comes over to the driver board, which would then actuate the stepper motor. This one's for the cold air. This one over here is for the hot air. And these valves will open or close anywhere between 0 and 50 steps to then adjust the hot and cold ratio to get the temperature that would be printed on here. So as we increase the temperature here, it's going to start to open up the hot valve.
In this project, I learned how to integrate different inputs from the system and be able to interpret them together in the code in order to create a meaningful output. And I learned how important the troubleshooting process is as you're trying to create a whole system, how many unexpected problems can arise, and dealing with a team to overcome those.
In this project, I learned how to communicate Arduino boards. The standard method of doing that is I2C, which for our purposes wouldn't work. So I had to learn about it only to not use it, and then find an alternative method, which then I created a byte using the digital input or output pins. And using that digital byte, I then would have to use bit masks and some Boolean logic to make sure that the values that were sent were the exact same values that were being read without any interference from the other pins.
I learned how to interface stepper motors. We had a stepper motor lab, but with the motor driver board and everything like that, it was a lot of work for me to learn that in a deeper sense. And interfacing that was a little bit of a challenge to get one to move and one not to move, and one to move with the other one when we needed it to move. So that was interesting, and getting correct solders and wires connected in the right places was a big deal for troubleshooting. So I learned how important that was.